All right. So integral calculus or integration. So integration is basically the opposite of differentiation. So let's say if you have a function y which is equal to 4x squared minus 3x plus 2. They ask you to differentiate this. You know that the derivative dy over dx is going to be equal to, you get the power multiplied by 4, that to be 8, you reduce the power by 1, and then minus 3, right? Is this it? And then what I'm going to do is, I don't want to have a fraction, so I'll multiply both sides by the dx which is in the denominator. So I'm going to remain with dy being equal to 8x minus 3 dx. And then I'm going to introduce the integral symbol both sides. Integral this side, integral this side. Now, there is a 1 in front here, even if we can't see it, there's a 1 here. So the integral of 1 with respect to y, that is what we mean by integral of dy. You are integrating y, you are integrating 1 with respect to y. So every time you integrate a constant, you just get the same letter you are integrating with respect to. So you are going to get y. So if this was the integral of 2 with respect to y, it would be 2y. Okay, and this is going to be equal to, for to integrate now, this side you can see we have got dx, meaning that we're integrating with respect to x. So 8x, if you integrate, it becomes 8x. Add the 1 to the power, it becomes power 2 divided by the same power 2. And then since you're integrating through with respect to x, just add the same letter you're integrating with respect to. Just add a constant c, because this integral doesn't have limits. 2 into 8, that will give you 4. So you see that it gives you back this one. That's why we say integration is the opposite of differentiation. That's why it is also referred to as an antiderivative. So this is actually the first method of integration, integrating as, or integration as an antiderivative. So that's the first one, which doesn't involve any special properties. So in a case you've been given, let's say they've asked you to find the integral, evaluate the integral of 8x to the power, let's say 3 minus 2 divided by the square root of x plus, let's say, 5 to the power 1 over 3 dx. You want to work out this integral. So firstly, you'll just be adding a 1 to the power. So this is going to be 8. You have got x to the power 3, so add the 1 becomes power 4, divide by the same power 4. And then minus. Now this 2 over square root of x, we can also write it as 2. Square root of x, we know that is the same as x to the power 1 over 2. So if it goes on top, it becomes x to the power negative 1 over 2. Meaning that I'm going to add to the 1 to the power negative 1 over 2. That will give us positive 1, right? So that will be 2x positive 1 over 2, not positive 1, but positive 1 over 2. The same 1 over 2 that you have found, also divide by it. Okay, and then plus 5, 1 over 3 plus 1. That is going to give us 4 over 3. And then divide by the same 4 over 3. Then add the constant c. So every time you don't see limits here, this is an indefinite integral, so you always need to put a constant c. So this gives us 2x to the power 4 minus 2 divided by half. That is going to be 4. X to the power half, that is square root of x. Okay. Now 5 divided by 4 over 3. Can also say 5 times. There's a question? Oh, yeah, I see. Actually, I left out an x here. We can't have 5 to the power 1. I thought I'd put an x there. Yeah, you are right. So we're supposed to have an x there. So this is what we are going to have. And then 5 divided by 4 over 3 is the same as 5 multiplied by 3 over 4. So it's going to give us 15 over 4. Then you are going to have x to the power 4 over 3. Then plus a constant c. So this is going to be it. Okay, is this okay? Are we good with this one? All right. Now the other one which comes as a result of antiderivative is when you are integrating trigonometric functions and also integrating exponential functions, integrating logarithmic functions. So you also need to know that. So let's start with trigonometric function. Now remember last time I had written a simple table. I said let the y-axis be sine x, the x-axis, the negative y be negative sine x, and then let this side be cos x, and let this side be negative cos x. So we said as you go in this direction, that shows the differentiation. Meaning that if you differentiate sin, you get cos. If you differentiate cos, you get negative sin. Now, if you go in the other way around, then that would be an integration. Okay, that would be an integration in this direction. Meaning that if I integrate negative sin, I get a cos. So the integral of cos of x dx, this is going to be sin x. Now remember we said the derivative. What did we say? What was the derivative for tan? D over dx of tan x. What did we get? Can you remember? Yes, so the derivative for tan is x squared, meaning that if you just have x squared, you differentiate, you are going to get you integrate, you are going to get tan x. And also, when you differentiate sec, you are going to get sec x tan x, meaning that if you integrate sec x tan x, you are going to get sec. So that is as an antiderivative. The other thing is for exponential functions, when you have got y being equal to e to the power, let's say 2x. If you want to differentiate this dy over dx, this is going to be, we said differentiate the power, the answer you get multiplied by the e to the power 2x itself. So if you differentiate 2x, you're going to get 2. So the answer that you get multiplied by e to the power 2x. So again, I multiply both sides by dx so that I remain with dy. That is going to be 2 e to the power 2x and then dx. So to remain with y, I'll integrate both sides. So the integral of dy is a y. Now to integrate an exponential function, what you do is differentiate still the power, okay? So write the function the same way it is, but differentiate the power. If you differentiate the power, you're going to get a 2. Now you're supposed to divide. When differentiating, you differentiated the power and then you multiplied. But when integrating, you differentiate the power but divide. So supposed to add the constant c. So this and this cancels. You see that this is going to be e to the power 2x, which is just that one we've been given. So this is how you integrate exponential functions. Differentiate the power, the answer that you get, divide. Now what of logarithmic functions? In this case, let me talk of natural logs. We know if we have got y being equal to natural log of x. Okay, y is equal to natural log of x. Let me say x plus 1. To differentiate this, the derivative can, let me just make it a bit better than this. Okay, let's say 2 minus 3x. So the derivative for this one, dy over dx, when you are differentiating natural logs, just get what is inside the brackets here. You you differentiate. So the derivative of 2 minus 3x is a negative 3. Okay, divide by the same thing that you differentiated, 2 minus 3x. So this is how you differentiate natural log. The log will not appear in the derivative. So if I multiply both sides by dx, I'm going to have dy being equal to negative 3 divided by 2 minus 3x. Okay, the dx comes here. Now I'm going to integrate both sides. So the integral of dy is y. Now I'm going, since the negative 3 on top is a constant, I'm going to remove it outside the integral. So I'm going to have 1 over 2 minus 3x dx. So every time you differentiate something that is in the form, the integral of 1 over x is always natural log of the absolute value of x. So every time you differentiate something that is in the form 1 over in a linear function like this one, you just get natural log. So what I'm doing is I'll first write this negative 3 because it's a constant, and then I'm going to get natural log. Okay, and then I'll write absolute value. You write absolute value because you always want an answer to be positive. So whatever is in the denominator here, you write it 2 minus 3x. You need to add the constant. Now, after you do that, you've seen that this answer that I've gotten is not the same as this one because they're supposed to give us the same thing because integration is an antiderivative. So you always divide. So look at what is inside here, differentiate it. So 2 minus 3x, if you differentiate, you are going to get negative 3. So differentiate, divide by negative 3. So this cancels with this. So that will give you back the natural log absolute value of 2 minus 3x. So this is going to be the answer. So that is how you differentiate, integrate natural logs. Is it okay? Are we okay? Now, after this, then you have got rules. That rules of integration, just like we have got rules of differentiation, also have rules of integration. Okay, for differentiation, I've got the product, quotient, chain rule, power, and power rule, and those other rules. So even here we have got rules of integration. The first one we should understand is the U substitution. Now U substitution is used for functions which differ by one power. Like you've got it can either be a product or a quotient, and the difference between them is like they differ by power 1. Okay, for example, you have got find the integral of x, and then you have got, let's say, x squared plus 1 to the power 3 dx. So if you look at this, this is just the x. And then inside here, you are multiplying by something that is x power 2. So the difference between these is a power 1, like they differ by power 1. So what you are going to do is you are always going to get the one which has got a bigger power, okay? You are going to let it be equal to you. So this will be let u be equal to whatever is inside the brackets there. Don't get the power of the brackets. So just get x squared plus 1, okay? Like that. And then from here, the next thing that you need to do is you need to differentiate u. Remember, if you've got y is equal to x, you say dy over dx. Why? Because you are differentiating y with respect to x. Now, since here we have got u is equal to x squared, then we are going to have du over dx. Okay? Because we are differentiating u with respect to x. But I'll not write the dx in the denominator because remember it was supposed to be du over dx. Instead, I'll just write du, and that is going to be equal to, I'll differentiate x squared plus 1. What are we going to get if we differentiate x squared plus 1? What are we going to get? I can't get you. Finish. Okay, so you're differentiating x squared. Just drop the power comes down. Then write your x, reduce the power by 1, so it's 2x. Okay, so du is equal to, remember it was supposed to be du over dx. Now I didn't write the dx in the denominator, meaning I'm going to write dx this side after I differentiate. So like this is the same as du over dx is equal to 2x. But instead of having the dx in the denominator, I multiplied both sides by the dx. Okay, is this okay? And then from here, I'm supposed to make dx subject to the formula. So dx is going to be divide both sides by the 2x. So dx is going to be du over 2x. So this is going to give us the integral of x, but where there was x squared plus 1, I'm going to put u. Remember that one is raised to the power 3. Where there was dx, we've seen that dx is du over 2x, so I'm going to put du over 2x. So see that this x and this x, they'll cancel. So that will give us integral. Now this 2 is in the denominator. So I'll take it outside the integral. Okay, that will be 1 over 2. Please don't write 2 because the 2 is in the denominator. That's why I've written 1 over 2. And then you have got u to the power 3 du. And this is going to give us 1 over 2. Now integrate just from what you know. So you have got u to the power 3 du. So integrating u with respect to u. So add the 1 to the power 3. That becomes 4. And then divide by the same 4. Okay. And then simply add a constant c because this is an indefinite integral. So this will simplify to 1 over 8 u to the power 4 plus c. And then substitute back u. So this becomes 1 over 8. Remember we said u was x squared plus 1. And then raised to the power 4 plus c. So this is the integral. Is this okay? So there are many different forms that they can bring a question that has to do with you using your substitution. I was thinking of something, let's say if I can make it the integral of x power 3, then you have got e to the power x power 4 dx. Okay, they've brought this integral x power 3 is equal to e to the power x power 4 dx. Now if you look at the x's here, you have got 1 is power 3, we've got 1 is power 4, so they still differ by a 1. So the best method here to use is use substitution. If you think of other methods, they might not be able to work out. So what we'll do is we'll get, so let u be equal to the one with a higher power, that is obviously x power 4. Okay, so after then, now you need to differentiate u. So du is going to be equal to, yes, if you differentiate u, what are you going to get? What are we going to get here? Okay, so look at just this one which is here. If you differentiate it, what are you going to get? Okay, 4x to the power 3. Don't forget to put dx. Alright? And then from there now I need to make dx a subject the formula. So dx is going to be du divided by 4x to the power 3. So therefore this becomes the integral of x to the power 3 e Where there is x to the power 4, remember I've said x to the power 4, let it be equal to u. So I'm going to put u. Where there is dx, I'm going to put du over 4x power 3. Seeing that x power 3 and the x power 3 will cancel. So I've remained with a 4 in the denominator. I'm going to take it outside the integral, so that will be 1 over 4 integral of e to the power u du. Now remember what we said when you are integrating natural logs, you differentiate the power. Okay, so we are differentiating u with respect to u. If you say, what's the derivative of x with respect to x? What do you think? If you differentiate x with respect to x, what are you going to get? Yes? Where? Which x? I'm asking you. If you differentiate x, what do you get? Yes, you get a 1. So here you are also you are differentiating u with respect to u, meaning that you are going to get a 1. So if you integrate e to the power u, the answer will be e to the power u itself. So that will be 1 over 4 e to the power u, and then just add the constant c. So this is going to be 1 over 4 e, and then you substitute back what is u. U is x to the power 4. Then add the constant c. So this is the derivative. This is the integral of this one. Is this okay? Okay, we can look at one more question on u substitution. Okay, so let's say we've been given the integral of, we can say, 4x to the power 2 divided by the square root of, let's say, 3x to the power 3 plus a 1 dx. So if you look at this integral, there is also a power 2 on top. Down you've got the highest powers power 3. Now notice that this is supposed to be a constant. It shouldn't be a letter again. Like, your substitution will not work if this is a letter also. Okay. So you have got two letters, but they differ by a power of 1. And on top, you only have 4x squared, meaning that if I add anything like plus maybe 2, your substitution might not be able to work. You have to use another method. Okay. So in other words, you have got something in this form, ax, and then you have got bx squared plus a constant raised to the power n, or this can be a fraction, meaning that this shouldn't be ax plus anything. Okay, and this shouldn't be bx squared plus cx. This c shouldn't be attached to any letter. So that's a form that you can use use substitution. So in this case, the one which is a bit complex, that's the one you are going to get. So you are going to say let u be equal to, so which one do you think we're going to equate to u? Okay, 3x to the power 3 plus 1, don't forget that. So and then differentiate u. So du is going to be, if you differentiate u here, what are you going to get? 9x to the power 2, not even 9 but 27x to the power 2 dx. Remember, we are differentiating. When you are differentiating, get the power, multiply by the number in front, and then subtract a 1. Huh? So don't mix that. So here now you can make dx sub to the formula. So dx is now therefore going to be du divided by 27 x squared. I can now come here. This is going to be the integral of 4x squared divided by, where there was 3x squared plus 1, I'm going to put u. But remember, it was square root, and we know square root is the same as power half. And then where there was dx, I'm going to put du divided by 27 x squared. So see that this x squared will cancel with this x squared. So we are going to remain with integral. Now on top here I've got a 4, down I've got a 27. So I'll bring that because the constant outside 4 over 27. And then we'll just remain with u to the power half in the denominator. Now I'm going to take that in the numerator, so it becomes u to the power negative half. And then I'll add the constant, or before I add the constant, see, this is going to be du. I have not yet integrated, so to add the constant. And then this is going to give us 4 divided by 27. Now we integrate u to the power negative half. That is going to be, we add the 1, so that will be u to the power negative half plus 1, that will be positive half. And then divide by the same power, which is positive half. Then just add the constant c. Now 1 over 2 can go into 4. That is 8 times. So that will be 8 divided by 27. And then instead of writing u to the power half, I'm going to write square root. And what was our u? U is 3x cubed plus 1. So I'll put here 3x cubed plus 1. And then add the constant c. So this is the integral. Is this okay? Elizabeth, is this okay? Do you have a question? Okay, I said this should be the last question, but let me just put this other one. Evaluate the integral. Let me even put limits between pi and 0 of x squared. Then we have got, should I put, no, let me not put units. Let me not put limits. So let's say just x squared sine of x cubed dx. Okay, this is our integral. So if you look at the variables, we have got x squared, we have got x cubed. So which one do you think is going to be u? Let u be equal to what? Okay, x to the power 3. So meaning that du is going to be, if you differentiate u, what are you going to get? Okay, 3x to the power 2. Don't forget dx. And then I'm going to make dx sub to the formula. That is going to be du. Yes, Elizabeth. On u. No, it is sine x to the power 3, not sine to the power 3x. So you only get the x to the power 3. Is that okay? All right. So this becomes the integral of x squared sine, but where there was x to the power 3, I'm going to put u. Where there was dx, I'm going to put du divided by 3x squared. And then x squared will cancel with the x squared. Okay, and then again, I'm going to take the 3, which is in the denominator outside the integral, since it's a constant. Going to have integral of sine of u du. So what's the integral of sine of u? I already wrote down that table, remember. What's the integral of sine of u? Are you sure? Negative cos of u. Then just add the constant c. And then substitute back where there is u. So this is going to be negative 1 over 3 cos, where there is u, you put now x to the power 3, and then plus c. So this is the integral. So basically this is integration by u substitution.